Okay, we have here today another integral. We've got the integral from 2 to 3 of natural log 1 minus e to the minus 5x dx. And this is one I did recently. I just wanted to do an alternative method. This method is going to be just a little bit longer using the power series for natural log 1 minus x. In the other video, we did a use substitution, which basically takes you right to a formula and the solution. So we're just kind of adding a couple steps, but I do think it's interesting to use power series on this, just noticing this is in a form really similar to this. In order to use this with what we have in the integral, I'm just going to kind of plug in the e to the minus 5x for our input. So if I have natural log 1 e minus 5x here, this is going to be the same sum from 1 to infinity of e minus 5. Distributed in the n power, we'll have this as e minus 5nx over n. So now for this first formula, when you derive this, this starts with our general geometric series formula where the convergence, the absolute value of x needs to be less than 1. Here we're looking for the convergence on e minus 5x less than 1. For this one, the bounds would be a problem because all of our x values are between 2 and 3. But here, notice it's not going to be a problem. When you plug 2 to 3 in there, all these values are positive and less than 1. So what we'll do is we'll just take this thing and we'll plug it back into the integral. First, I can take the minus sign out front, and so we're going from 2 to 3 of just this same sum. But then let's just swap the order of the integral and the sum. We can do it. We've got the convergence, the absolute convergence we found right here. Now next I can basically integrate this, but inside the integral here with respect to x, the n is just a constant. So let's keep that inside the sum, but outside the integral. So we'll just bring that out here, and we'll have it as 1 over n times this integral. But now integrating this is going to be real easy. This is just going to be e minus 5nx, and then we'll take the constant part out in the denominator, so we'll have 5n here. Just let's bring the minus over there, and we'll have this inside of our sum. And now for this thing, we just need to evaluate from 2 to 3. But when I do this, let's actually cancel the minus sign. So minus times minus is plus. And also the 5 here, we can bring that all the way out front as a constant. So we're going to end up with 1/5 the sum. Combining 1 over n times 1 over n, we'll have this as 1 over n squared here. I want to put down pi squared over 6, but let's not get too excited yet because we still need to evaluate this part. So if I plug in 3, this part's gone, remember? So we plug in 3 here. This is going to become e minus 15n. And then for the second part, plug in 2, this is going to be e minus 10n. And then with this thing, all I want to do is let's break it up into two sums and just write it a little bit differently. So we're going to have 1/5 in front of everything. So let's bring that way out in front. And then like for the sum, we'll write it as n equals 1 to infinity. So for this first sum, it's going to be over n squared. This I can write as 1 over e to the 15 all to the n. For the second one, let's write it the same kind of way. Just write it as a sum over n squared, and we'll write it as 1 over e to the 10 all to the n. The reason I write it out this way is I want to show that it's in the same form as the dilogarithm. We have our formula for the dilogarithm in terms of the series up here. And so I've grouped it this way. And sorry, this shouldn't be squared. This should be an n right here. So notice we've got the sum where we have the n squared in both these. And then I've written this as some constant value to the exponent n, just like that. So like our x in this formula is going to be 1 over e to the 15 here, 1 over e to the 10 here. So putting this together, I can write it all over 5. This first piece is going to be just dilogarithm of this input, 1 over e to the 15, minus the second one, which is just dilogarithm 1 over e to the 10, and that's it. Okay, so there you go, not too bad. We just added a couple steps. We had to do the integration and some algebra, but then quickly to our formula using the dilogarithm. Okay, that's it for today. Thanks everyone for watching. Have a good day.